What's going on, guys? Welcome back to the channel. In this video I want to show you how to apply Cypress Smart Network configuration to ESP32 firmware code. If you don't know what is Cypress Smart Network, please watch the previous videos. As I mentioned in the previous video, Cypress has an open source repository. For now, clone Smart Device Test GPIO git clone. It takes a while. Then open the VS Code. Open VS Code and open constants.h. Most of the configuration should be done in constants.h file. Now open the Cypress Terminal application. In Terminal Edit page, go to Network Configuration, and according to Terminal Configuration, the access point name should start with Cypress _ Wi-Fi _. And as you can see in firmware code, it is start exactly with equal value in Android application. And imagine that if you have more than one device, to distinguish these devices, we have to concatenate a unique ID to the access point name or SSID. And I use the last 6 digits of MAC address, but you can define a dedicated ID and use that ID. The SSID prefix and suffix command is set to SSID : and s. As you can see, it is exactly equal in firmware side. It is also the same for password, prefix and suffix. And for example, if I change SSID to, I don't know, pre1, we should do the same change in firmware side. But let me return it back to SSID. TCP port number and UDP port number is set to 1234 in both sides, and a scan command is get_info in both sides. Please consider that do not remove \r/n in firmware side, and remote scan response is ag in application configuration and ag in firmware side, and apply all of these changes. Hold the device item, open device edit dialog. Name is dev1, device name dev1, device type dev type 1, dev type 1, terminal name is terminal1, major ID. We have major ID in here and in our email. It is also possible to paste it here. And please consider that terminal name and device name must be in lowercase. Then open your email. If you remember from the previous video, we save certification and the private key in our email, and paste the certification here. Then it is required to add \n/, and for private key, have to paste AWS IoT private key \n/. Please do not change root CA. And one more thing remains. All devices with the same type must have a unique MAC address device SSID, and miner ID. Imagine that if you want to manufacture thousands of devices with a type dev, type 1, or for example, temperature device, each of these devices must have its own MAC address, device SSID, and miner ID. But all other parameters should be exactly equal. In this video, I want to test GPIO pin. I will send on-off command to the device and set or reset the GPIO pin of the device and return the feedback response to mobile. For this purpose, let me open the device GUI page and delete all views and define 4 new on-off button. Audio, CR, please. Well, now I set the button value of 1 off to off 1 enter, and please add enter at the end of each button value. On 1 enter. For the feedback side, RN1 and RF1. It is not required to add enter in here. It is also the same for other buttons. Apply all these changes in GUI page for the device. Now all network and device configuration has been done. We should add some bunch of code in firmware side to handle on-off command, but first we should do something else. And now we have to flash the board. Before flashing the board, TCP server DB in TCP server.h file should be defined, and in AWS IoT handler.h we should change db underline AWS IoT from undef to define. In this way we can log the commands that receive from the mobile phone. Now flash the device here, run idf.py flash monitor-p and the name of the USB port that your board is connected, then press enter. It takes a while for the first time. The device is now loaded with the new firmware. Back to the main page of terminal. Imagine that your client has bought one of your devices. In the first step, client should put the device in access point mode by restarting the device 5 times in a row with an interval of 1 second. Let me do it. And then, as you can see, the device is now in access point mode. Then the client can pair the device to a specific router. Open the pair page, open the Wi-Fi setting, I want to pair the device to this router, then back to the Cypress pair page. and enter the password, because it is not the first time that I want to pair to this router. The password has been saved, and press next. Everything has been explained to the client, to how to, for example, find the device in Wi-Fi list, and how to uh, select it. And as I mentioned, the device access point name should be start with Wi-Fi underline Cypress underline Wi-Fi underline something. Select in this device, return back, press next, and the device is paired to my router. Okay. In here, Cypress application wait to reconnect to the router. If it cannot connect to the router, just Wi-Fi, open the Wi-Fi setting and connect manually to the router. As you can see, the Cypress underline Wi-Fi underline the MAC address is not found now, because it is now switched to station mode, and it is not possible to find it in Wi-Fi list, because the device is not working in access point mode. And select AP for test. It automatically returned back to the terminal main page. And now when I press search, I should be able to find the device. Great. As you can see, the device has been found. In here, I just find the device locally, because my router is not connected to the internet, and for this reason it shows offline. But I try to find a clip and show you also the remote communication. Now, when I open the device, as you can see, when I send any data, I can receive. Exactly, I receive the data that I have set in edit page. I am receiving this error because the device is not connected to the internet, and the device is trying to connect to AWS, and for this reason I have received these errors. But it doesn't have any effect in the performance of the device, and as you can see, everything is working well. As I mentioned, now is the time to add some code to, for example, do something when off command or on command receive. To handle local commands, we have to add some code in TCP server.c, and to handle remote commands, we should add some codes in AWS IoT handler. Before adding this code, let me explain something. Two different functions are defined to handle local commands and remote commands. It is mainly because maybe in some condition you want to apply different operation if the command is received locally or remotely. Let me return to the code. Uh, in process underline TCP underline data, to handle local commands, it is possible to uncomment this code and write the condition and the operation in here. I have already prepared the code. Let me copy here. Well, when, for example, off1 is received, the GPIO underline out underline 1 will be 0, and this RF1 will be sent back to the to the mobile phone. And it is also the same for other comments. As you know, these values are exactly equal to these button values that we in that we set in a device edit page. Now in here, it is for local commands, and for remote commands, we can also add the code in here. In process underline AWS underline IoT underline command, paste the function here, but we should also add else. Great. Now is the time to flash the board to see if command handlers work correctly. We have an error line. Okay, we have to delete this one. Here, write down again. We have another error in we have to change it to command. Sorry. Okay, great. It takes a while to flash the board. And now when I send data from a mobile phone to the device, as you can see, when on1 receive, the RN1 send back and the status feedback will be blue, and it is also the same for off. And if I send on 2, 3, 4, it is also the same behavior exactly for all buttons. Well, I think that's enough for this video. If you have any idea or any question, please leave a comment here. Thanks for watching. See you soon.